is grade 4, unit 1, lesson 1, and it's the first day of going after 4.08.4, which is the factors of multiples standard. Today, you're only focusing on multiples, understanding if a number is a multiple of a given factor by asking yourself, coming down here, asking yourself if a given whole number is a multiple of a given one-digit number. So here I have the number 12. I can ask myself, if I know that 6 is a factor of 12, I know that 12 is a multiple of 6 because 6 times 1 is 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is, and so on and so forth. Our aim for the day is mathematicians will be able to define and identify. Those are your key components there. But actually, later on, you have to not just define and identify, but actually create lists. So it's not just looking at a number and identifying it, but being able to say, like, what are the multiples of 6? This is a huge part and the crux of what you're doing today. And the thinking question you want kids to go after. I can determine multiples of numbers. I can determine multiples of numbers or whether a given number is a multiple of another number by asking myself, what are the possible products of this number and another whole number? So, possible product of this number, the number 6, and another whole number, 1, 2, 12, 3, 18. So you're asking yourself, 6 times what gives me what? 6 times what gives me what? 6 times what gives me what? And that what, the end of it, is actually the multiple. The next day we'll get to factors, and it feels more like the inversion of this. I'll say this again and again. Exemplar student response. If you want scholars to be able to write this, you need them to be able to say it, which means you need to do a significant change to the work you're doing in terms of your intro to new material, discussion, workshop, and any type of turn and talk time. The high quality speaking and listening needs to be pushed. Go right to the exit ticket, missing big problem, missing tasks, because it's not aligned to us. But again, this written response needs to be aligned to the work that we're doing. Here's an example of a rigorous but not highly rigorous problem type. Which one is not a multiple of 8? So skip counting by 8s or creating rows and amount in each row of 8 to see which one of these does not fall into that list. This is the visual model that they've created for you. It is not exemplary if you want the takeaway to be multiples of the product of a given number and another whole number. It's stated here, but there's never a place that really captures the multiplication component to it. And so prior to you making the visual model, I've sent you one before that has a monster on it, and it actually has a monster thinking through, if I'm a 5, what are all the multiples of me? 5 times 1 is 5, 5 times 2 is 10, and those are multiples of 5, but not just doing the multiplication, but then also showing all of them in order. These are all multiples of 5, because I know that 5 times 1, 5 times 2, 5 times 3, and so on and so forth. Okay. It's a good problem. I actually really like this problem. It's more ideas. It is your responsibility to go through the introduction component, mark it up like crazy so that you are ready to get the key takeaways. Achievement First has spent a lot of time and money writing these. Please also then go to workshop, lap 1 procedural, lap 2 conceptual, and then the check for understanding. This is the mid-workshop interruption that needs to happen every day. So between 5 and 10 minutes in, you need to pause the class. If this question is not rigorous enough, you don't need to go with it. And then the moment that workshop ends, we have a 5-minute discussion built in where we're actually building in more discourse time for kids before they get to the IEP. It's your last time to really get a data point on the whole class. All right, I'm gonna talk you through this. I completed this problem, and not the whole page. I completed this in advance, and I'm just going to talk you through the way I went at it, and then I'm going to find one more problem. The key takeaway from the word problem: Kesh is at a farmer market to buy strawberries for tarts. The recipe calls for 5 strawberries per tart. At the market, strawberries are sold in sizes shown below. 8, 22, 30, and 53. If Kesha does not want any leftover strawberries, which bags could she use to make her tarts? So what you want kids to understand is they're thinking about 5 times what. Does 5 times what give me any of these amounts? Because ultimately these are the products. This is your factor, and you're looking to see if there's any way you can use this to create the product, which is also the multiple. I spent time here instead of up here today because I feel like this gives you the straightforward idea. I'm gonna model is 13 a multiple of 3? How do you know? But I'm gonna model it up here with this problem type, just as straightforward. So big question, which bag of strawberries? Task 1, I'm gonna find multiples of 5. Task 2, identify correct bag. This is my annotations. My representation is 5 times what gives me bag. And I'm gonna put question mark next to the bag because I really want it to be small, medium, large, or jumbo. I did the work for down there in my space up here, which is upsetting. Solve. Okay. I am asking myself 5 times what gets me close to these numbers. I have 8, 22, 30, and 35. As an adult, I can skip count. Their problem just asks you to skip count and prove your thinking with a multiplication fact. So I think you could do both 5, 10, and that's 5 times 2, 15, 5 times 3, 20, 5 times 4, 25, 5 times 5, 30, 5 times 6, and I already know 8 doesn't work because it doesn't fall in the sequence. 22 doesn't work because it doesn't fall in the sequence. 30 works right now, and I actually have to go all the way to 55 to disprove the jumbo. So the large becomes the answer because it's a multiple of 5. And I can prove that by saying this is your complete sentence answer. What's the girl's name? Kesha. Kesha needs to buy the large bag of strawberries. She will have no leftovers. I'm gonna write that in abbreviation so I have space. 5 times 6 equals 30, and I need to actually push that a little bit further, but I don't have the space right now. Throughout this, the reason why this is so important is when kids get here, multiples of 2, multiples of 5, multiples of 9, circle, square, triangle, it becomes so routinized that you lose the idea and go with the procedure. So anytime if a child was to go through and circle 2, 4, 6, 8, your question would be, how do you know that's a multiple? How do you know that's a multiple of 2? I know because 2 times 2 equals 4. And so the way we can make this stronger is by doing that to prove and to give the clearly explaining thinking gets pushed through that.